Hi. Now we'll learn few more types of sets. These are names given. So the very first one we learned in the past. What are the things? Empty set and uh, universal set, subset. Now we learn few more types. So the very first one is disjoint set. Disjoint set sets. So disjoint is not one set. We say like okay, it is disjoint, but to make disjoint sets plural, that means it is not a single set. Two sets when we call two sets as disjoint sets. So we can't say like okay, one set is a disjoint set. No, that doesn't make any sense. So when we have two sets, we can compare and say these two are disjoint. So we need two sets. That's the reason it is plural. So when we say disjoint sets, so when one set is like having elements 1, 2, 3, 4. So now I switch back to the regular or mathematical things like, so when B is having 5, 6, 7. So there are no common elements between A and B. So A is having 1, 2, 3, 4. B is having 5, 6, 7. There are no common elements. So in that case, how the Venn diagram will be? So Venn diagram will be having mu. It could be natural numbers. And A is having, this is my A, this is my B, because A and B doesn't have any common elements. So there is no point of like having an intersection. So I have 1, 2, 3, 4. Here I have 5, 6, 7. So there is no joining between them. So the name itself is says this is in English. It is like we use it for negative thing. So disjoint. There is no joint. So there is no joining between these things. So that's the reason A and B are called, A comma B are called disjoint sets. Called disjoint sets. Because there are no common elements. So in future, if there is any what to say, if somebody gives like okay roster form like A equal to 1 2 3 4 and B equal to 5 6 7, then you can easily guess it there are disjoint sets. But in exam he might tell like okay PQ are disjoint sets, what is A intersection B, something like that. So if PQ are disjoint sets, what is P intersection Q? So A and B are disjoint sets. So there are no common area. What is A intersection B? Nothing. Nothing means called empty set, void set. So you can use all the synonyms of them, or you can simply represent with the mathematical form pi. So when P and Q are disjoint sets, there is no common area. So you can say pi. So that is what here. So there are another few things like cardinality, those things also will come to that point. What to say, we'll discuss more when we discuss cardinality. Next set is equal sets. Equal means same. So this is also plural thing. So can I say like I got equal marks? Equal means you have to compare with something else. So like me and my friend got same marks, equal marks. That means I'm comparing myself with my friend. So equal means you always need a second thing. So you can't say like okay I'm equal. You are not equal. Your height is equal to your friend. Something you need a second one. So that's why equal, disjoint, all these things you need to compare with somebody else. You can't be yourself as equal set or something. Okay. So when we call A and B are two equal sets, sorry. When we every element of A should present in B and every element of B should present in A, then they are equal. I'm just giving the same thing. So if you write it in a, if you take an example 1 2 3 4 and b equal to 1 2 3 4, then these two are a and b are equal set, because 1 2 3 4 are there in one here and all the elements here they are here, so they are called equal. So a and b are equal, so you can easily tell a equal to b, isn't it? So the mathematical definition, so you need to understand the definition is something that should be very clear and it should be proven all the time. That's the reason we always go by the definitions. The definition of a equal to b is every element of a should present in b, like 1 is should present, 2 should present here, 3 should present here, 4 should present here. Good job. And it won't say it won't stop there, and every element of b should present in here. 1 should be present here, 2 should present here, 3 should present here, 4 should present here. Then only they are called a equal to b. How we write every element of a should present in b? That is a subset of b. Every element of b should present in a. How we represent? This one. If every element of a should present in b and every element of b should present in a, that means a equal to b. Did we derive the statement? When a subset are equal to b and b subset of a, then a equal to b. The words what I am saying, I wrote it in using the symbols. Every element of a is present in b and every element of b present in a, then a equal to b. So what happens? Let's take a equal to 1 2 3 4 and b equal to 1 2 3 4 5. Can we call these two are equal sets? Let's see. What is the definition? Every element of a should present in b. 1 is here, 2 is here, 3 is here, 4 is here. Good job. A subset equal to every element of a is present in b. This is correct. It doesn't end there. It should also b, every element of b should be there in a also. So let's see. Every element of a, I'll take 1, it is there, 2 there, 3 there, 4 there, 5 missing. So this statement went wrong. Every element of b not in a, so a not equal to b. So another symbol, if you don't know, this is not equal. So just like belongs to, does not belongs to, equals, not equals. So this is how we define the equal sets. Next we are going to learn about finite and infinite sets. Finite set. So let's go with finite set first. So finite set is, you can see the element should be countable. So like a equal to 1 2 3 4. So how many elements are there? 1 2 3 4. 4 elements are there. I can count it. So that is called a finite set. You can get a finite number. So for example, a equal to number of pencils in my box. I can count, I can go, pencils in my box. The statement should be not number, just pencils in my box. My set is color pencils in my box. So I can go open your box and I can count number of pencils in your box. It could be 12 or 24, but there will be a certain number. So that is countable. It's a finite number. That's why it is called finite set. So what is the definition? So if you could able to count the number of elements, so if you get a definite number, that is called a finite set. So the opposite is infinite. So number of elements is, you can't measure that one. Infinite set, infinity. So if you want to write it in a roster form, so it will be 1 2 3 4 whole numbers. So or else you can write it with W also, whole numbers. So it would go on, it never end. So this kind of a set is called infinite set. Or so some people think that if you write it in a what to say, a set builder form, then it is an infinite set. No. So if you write it the whole numbers in this one, the set of all x such that x is a whole number. Whole number. So it never stops, it will keep on going. So this is like, okay, if you want to write it in a roster form, it will be like this. And if you want to write it in a set builder form, it will be like this. So this is a infinite set. You can't, what is the count? How many elements are in this set? It will be go on, infinite. So since the elements inside the set are infinity, so we call the set is infinite set. Okay. So same concept we will learn about cardinality. Cardinality. Cardinality is nothing but number of elements in that set. Number of elements. So what is the cardinality of this set? So what is the number of, we represent with n of, number of elements in A. Number of elements in A. A is, how we write A? 1 2 3 4. Number of A, cardinality of A, or number of A is 4. Number of elements in this one is 4. Can we define the number of in whole numbers? It is infinity. So in your textbook it says like, okay, cardinality of infinite sets, we'll learn it in the higher classes. So leave this topic here, but finite sets, you can write number of elements in A is 4. You can write it like this.